acceleration formula is A equals VF minus VI over t. So acceleration equals final velocity minus initial velocity divided by time. Because we're going to rearrange this formula a whole bunch of times and we're going to be writing these symbols over and over again, I'm going to not draw the arrows over the symbols so I can show you easily how it's rearranged, but know that the arrows are supposed to be there because these are always vectors in this formula. First thing we're going to do is solve for t. To solve for t, it's actually quite easy. Because t is on the bottom, anytime you're looking for the thing on the bottom, you just swap it out with the thing on the other side of the equation. So the formula for t is t equals VF minus VI over A. This is one very important formula. The second two rearrangements, looking for VF and VI, we're going to take an intermediate step and do it in steps to understand how it's rearranged. I'm going to start by moving the t over to the A so they're on the same side. This gives me AT equals VF minus VI. So I just moved my t up to join the A. If I want to solve for VF, I can then move the VI over. The opposite of subtracting is adding. So AT plus VI equals VF. This can just be reversed or flipped, so I get VF equals AT plus VI. So here's the formula if I'm looking for VF. I can use this intermediate formula we created, though, to find VI. So I'm looking for VI. I move AT away. The opposite of adding AT is subtracting. So now we have VI equals VF minus AT. So these are the three major rearrangements of the acceleration formula. T equals VF minus VI over A. VF equals AT plus VI, and VI equals VF minus AT. If you find this difficult, I recommend practicing these rearrangements, whether you're rearranging one, which you follow this way, or you're rearranging for VI, following the pattern this way, or rearranging for T. But you should practice that. If even with practice you find it hard to get, sometimes memorizing these three rearrangements is what you need to do. Either way, you need to be able to find these rearrangements so you can solve problems. For example, a car initially traveling (7 meters per second), let's call it 7.0 meters per second, accelerates at 10 meters per second squared to a top speed of 15 meters per second. How long did this take? So this question isn't looking for acceleration. It uses an acceleration, but it's asking for time. So we have VI, because it's initially traveling, is 7.0 meters per second. We have acceleration is 10 meters per second squared. And we have a final speed of 15 meters per second. And we're looking for time. A is VF minus VI over T, and we're looking for a rearrangement for T. To solve for T, we switch A and T, so T equals VF minus VI over A. T equals 15 minus 7 divided by 10. 15 minus 7 is 8 divided by 10 gives us 0.8 seconds. Looking at significant digits, I have 2 significant digits, 2 significant digits, and 2 significant digits. So my time is 0.80, has 2 significant digits. In the next example, we're going to look for the car's initial velocity. A car takes 10 seconds to stop with an acceleration of 0.40 meters per second squared south. What was the car's initial velocity? Well, we have t equals 10 seconds. It's coming to a stop, so VF equals 0. A equals 0.40 meters per second squared south. This is like 0.40 meters per second squared negative for the south. VI equals question mark. Just looking at the situation, I can figure out what direction VI is going to have. Since it's coming to a stop, that means it's slowing down. The acceleration has a direction of south. If it's slowing down, the velocity should have the opposite direction. So I can predict that the velocity is going to be positive, which will mean north. And we can see that we're right when we do the steps. The formula for acceleration is VF minus VI over t. And we're trying to rearrange this for VI. I always rearrange this in small steps because it's easier to see the rearrangement if we do it in pieces. We start by moving the t. AT equals VF minus VI. And then we move the VI to get AT plus VI equals VF. And then we move the AT away from the VI to get VI equals VF minus AT. So now VI equals, VF is 0, minus, brackets, negative 0.40 times time, which is 10. 0 minus 4.0 negative equals negative times a negative makes a positive 4.0 meters per second. Now it's positive. Because it's positive, we can deduce that it's north, which was actually the direction we predicted. So VI is 4.0 meters per second north.